Okay, so let's talk about conservation of momentum. So let's start by quick reviewing the expression we came up with in the last video for Newton's second law, which was the force is equal to the time derivative of momentum. Now we should have been a little more careful with this because it's not just a force, it's actually a net force, and more than that, it's a net external force. Okay, so that leads to the question, what if there is no net external force on a system? Acting on the system. Okay, well, if we go to that Newton's second law, net external force is now equal to 0. That means the time derivative of momentum must also be 0. Now interpret what that means. Derivatives are rate of changes, or derivative is a rate of change. So this means that the change in momentum is 0. Okay. So change in momentum is 0 if there is no net external forces. Well, those of you in calculus know if the derivative of something is 0, then that something must have been constant. So that means in this case the momentum of the system must be constant. Okay, so that means if the change in momentum is 0, then the final momentum must be equal to the initial momentum. So, in other words, whatever momentum we started with, we must end with. Alright, so let's do a quick example with that. Okay, suppose we have a cart moving along level ground. We'll give the cart mass, we'll say it's a 1,000 kilogram cart, and it's moving with a speed of 10 meters per second towards the right. Okay, so now we'll just say sometime later, while it's moving, we drop mass into it, maybe like sand or gravel or something. So like a bunch of particles just kind of falling into this thing. But we'll say that about 200 kilograms of this stuff fell into the cart. Okay, so we've now increased the mass, and as a result, what is going to happen to the velocity? So the net external force here is 0. The system consists of the cart of 1,000 kilograms and the mass of 200 kilograms. So even though the mass did fall in and impact the cart, you got to think of Newton's third law. As the mass hit the cart hit back, so those internal forces cancel. So there's no external forces, which means our final momentum must be equal to our initial momentum. So the total momentum of the system is basically the sum of the two momentum for each object, the cart and we'll say G for gravel. Okay, and then after the gravel falls into the cart, it becomes one large mass, so add the two masses together, times the final speed. Okay, so let's just throw the numbers in and crunch it out. 1,000 kilogram cart moving at 10 meters per second. 200 kilograms of gravel, but initially the gravel was not moving, so their velocity is 0. Then the total mass is 1,000 kilograms plus 200 kilograms, and then times the unknown final velocity. So 1,000 times 10, that's 10,000. 1,000 plus 200, 1,200 kilograms. And then we're solving for V, which we will get as 8.3 meters per second.